And welcome back. This lesson is on antiderivatives. Antiderivatives involving inverse, it's a long title, circular functions. There we go, long title. But basically what we have is this. If you have the integral of 1 over square root a squared minus x squared dx, what that is equal to is sine -1 x over a plus c. That's our first, if you see this pattern come up somewhere, then you know the integral of that is the arcsine function. Similarly, we've got -1 over a squared minus x squared, and you should remember these from the chapter on differentiation. That's cos -1 x over a plus c. And the last one is a over a squared plus x squared dx. What that is that's our arctan function, x over a plus c. And so there are your three important forms. So when you're integrating, have a look out. If you ever see any of these three forms or something that resembles those, then that's something that you can look at to use an arcsine, arctan or arccos for. So let's just jump into some examples. Just going to do a couple to sort of show you. So an example might be, let's do integral of 5 over 1 plus x squared dx, something like that. So you look at it and you think to yourself, well, what form is that? Well, that looks like our arctan function there. Our arctan is one, well, think about it to yourself. This is what you got to think. The arctan function, there's nothing in front of the x squared. In other words, there's a coefficient of 1 in front of there, and that's what we've got in this case. And here, this is our value of a squared, because you've got a squared plus x squared. So in this case, a is equal to 1, and this is key to remember here. A is equal to 1. So to be able to anti-differentiate this, what we want is this top line to be equal to 1, because we know what that's equal to. So what this is equal to is the integral of 1 over 1 plus x squared, like that. And if we do this right now, that would be the arctan x. That would be as simple as that. But this is not equal to this, obviously, but what we need to do is multiply this by 5. And so what we can do is just write a 5 out the front like that. It's 5 times that. That's equal to that. That's fine. The other thing you can do is this 5 can go, because it's a constant, it's not part of the integral, it's not an x, doesn't involve an x or anything like that. So that 5 could go outside of the integral sign. So what we can do is just do that. So I'm going to put that 5 out the front like that. And so there we go. So what this is equal to 5, and the integral of this is equal to tan -1, and it's x over a, which is 1, but we don't need to write it like that. It's just 5 tan -1 x plus c. Just done a plus c as well up there. So that's your answer. So the steps are, look at it, recognize which form it might be, and try to rearrange it so that it looks like the function that we want. Okay, I'll do a couple more examples to show you different sort of stuff. What about if we have 3 over, let's do 16 minus, I'll choose reasonable numbers, 9x squared. Okay, something like this. What's this equal to? Alright, so firstly, it's not tan because there's a square root down the bottom. It's not arctan. So it's either usually tan or sine, because we don't really use that much. But in this case we want sine. And just a little reminder what sine looks like. It's this. It's 1 over a squared minus x squared. That's what we want it to look like. Okay, I'll just leave that there as a little reminder. So at the moment there's a number of problems. Firstly, the top line is 3, not 1. But we can take that 3 out the front, that's not too bad. Also here there's a 9 in front of the x squared, and we don't want anything in front of the x squared to make it look like that. So what we need to do first off the bat is to factorize that out, to try and get that number out of there. So what I'm going to do is take 9 as a common factor out of there. So if I take 9 out of there, I get 16/9 minus x squared. Perfect, so that's good. Oh, this is going to turn out well. That was just a fluke, believe you me. Dx. Okay, so I've just taken 9 out as a factor. Now when that 9 comes outside of the square root sign, what happens? Well, when that 9 comes out the front, you'll get, that'll become a 3, and inside the square root sign we'll have 16 over 9 minus x squared dx. Now, it was just luck, believe you me, I didn't want it to be an easy one, but they'll cancel out and you'll just left be 1 on the top line. And then we've got something fairly similar to what we've got up here. That's our arc sine derivative. So here, what is a equal to? Well, a will be the square root of 16/9. So a will be the square root of 16/9, which is 4/3. So that's our value of a in this case. So let's make the substitution. We've got a 1 on the top line. That turned out very well. So what we've got is sine, arc sine, and what it is x over a. That's as simple as it gets, plus c, and I'll just fix that up. That's arc sine of 3x over 4 plus c. There's your answer. Okay. So with these ones, I might just do one more because I think I've got time. But what you're trying to do is making it look like the function that you want. I'll just try to find a sort of tricky one. Let me try something like this, maybe 5 over 7 plus x squared. Let's do something like that. That'll do. So what we want to do is have a look at it, recognise what it is. Well, it's not sine or cos because there's no square on the bottom, but I'm pretty sure it could be tan. Reminder of what tan looks like is this a over a squared plus x squared, like that. So it's pretty close to that. We just need to sort of figure out. There are a number of problems here. The problem is that, well, what's a have to be equal to here? Let's just have a think about that. If we're going to have it in this form, a must be the square root of 7. Okay, so it must be the square root of 7. So what we need to do is get it into this form somehow. So let's firstly write this in the form that we like. So on the bottom line, it will be 7 plus x squared. That's fine. But if a is equal to root 7, we want the top line to be a. And so we want that to be root 7. What have we done to this? Well, to get this back to what its original value was, we'd need it times it by 5 and divide it by root 7. So it would be something like that. And can you see how that root 7 would cancel out with that root 7, just be left with 5 on the top. So that is equal to that. So that is correct, that step there. And so always be careful with it. Just check you're working out with these things. We've put that fraction in to make this root 7 equal to 5. Okay. Once you've got this correct form here, and you can move forward. So what's that equal to? That's equal to 5 over root 7 times, now do the anti-differentiation. This is your tan, arctan function, and it will be x over, what's a? A is root 7, so x over root 7 plus c. There's your answer. You could tidy this up by rationalising the denominators here. Not overly important till you get to the end of a question. You won't get penalised for that in the exam. If you like to do it to neaten things up, that's fine, but no need to. That's inverse circular functions to help you integrate. Enjoy.